Hey, hello and welcome to today's GFG problem of the day. Hope you're doing well. So let's see today's problem, sorted and rotated minimum. Okay, so what the problem is saying is, we'll be given a sorted array which is rotated at some unknown point. The task is to find the minimum element in it. So let's see an example array. So here is an example array. So here, as the problem is saying is, the array was sorted, but it is rotated at some unknown point. Okay, and let's see, like for example, here, if you see, right? So this part is sorted here, right? And 6, 7 being the greater elements, that means it was right rotated. Okay, it was right rotated by two places. Okay, okay, rotated in right direction by two places. Okay, now what we want to do is we want to find out the minimum element, and which is that minimum element? It is this one. Okay, now if now let's see how we can solve this problem in naive approach. Okay, so what will be the naive approach here? For example, we'll iterate I equal to 0 to n, right? And what we are going to do is we are going to have a minimum variable which we are going to assign with or initialize with infinity, and which is what is infinite? It is nothing but integer max value. And what we're going to check here, if min is greater than r of I, that means we have found a smaller element, so we'll assign r of I to min. Okay, so this will be the naive approach because it is going to take O of n. And since we have a better approach to solve this problem, and hence we are calling this as a naive approach. Okay, so let's see how can we solve this in optimized way. Okay, so what we can do is let's see. So since we know that the array was sorted, okay, and it is rotated at some point, okay, at some point, and also the problem is asking to search an element, and that element is should be minimum. Okay, so what algorithm comes to mind? Definitely it comes binary search. Okay, so we are going to use binary search, the modified version of binary search, in order to solve this problem. So what we're going to do is we're going to take a left pointer and a right pointer, right? And we are going to uh, what we do in binary search, right? We take mid equal to L plus R by 2, okay, which is nothing but 0 plus 6 by 2, which is 3. 6 because R is pointing at 6th position, L is pointing at 0th position. Okay, so our mid is 3. So where is our mid pointing? It is pointing here. Okay, now what are we going to check here? If r of mid, if it is greater than r of right, okay, if it is greater than r of right, that means the smallest element, the smaller element, the minimum element is on the right side, is on the right side. For example, let's see what I'm trying to tell here is, for example, if this was array 4, 5, 6, 7, right? It is a rotated array 1, comma 2, comma 3, right? So according to the mid, where would the mid be? For example, if L is here, R is here, mid would have been here, right? Now see, if you check this condition, r of mid is greater than r of right. So yes, this condition matches. So, and what we are saying here is, if this condition matches, r of mid is greater than r of right, that means the smaller element, the minimum element is on the right side, is on the right side of the mid. And that is why what we are going to do, L equal to mid plus 1 in this case. Mid plus 1 we are going to say. Okay, because the smaller element is on the right side, and hence our left should start from here, right? That's what it is saying. Okay, else coming back to this particular problem now, this particular example. Else, if r of mid is not greater than r of right, in our case r of mid is not greater than r of right, that means the smaller element is on the left side, and hence what we want to do is um, r equal to mid, will say r equal to mid. Okay, r equal to mid. Because why we are not doing r equal to mid minus 1? Because it may be the case that mid itself, the element which is pointing, right, it can be the minimum. It can be the minimum. It is possible. Okay, so r equal to mid we are saying, so r will point here. Okay, now again we are going to run a while loop, right? While L is less than R, we are going to say, right? And this condition. Okay. So now R is pointing here, R L is pointing here. What will be the mid here? So, so 0 plus 2, right? R is pointing at second position. 0 plus 2 by 2, 2 by 2, 1. So our mid will point here now, right? Our mid will point here. Now what are you going to check? Is mid, according to this particular first condition, right? Is mid, r of mid greater than r of r? Definitely it is greater. That means the smaller element is on the right side of 7 of this mid. And yes, it is a case. So what are we going to do in this case? L equal to mid plus 1 we are going to do. So our L is pointing here, right? R is pointing here, L is pointing here. Again, what we are going to do? So 0, 1, 2, 0, 1, 2, 3. Okay. So 0, 1, 2. 2 plus 3 by 5 we are going to say. 2 plus 3. L plus R, right? Divided by 2. So mid will be 2. 5 divided by 2, mid will be 2. So mid will be pointing here, right? Mid will be pointing here. Okay. Okay. Now, what are we going to check again? What are we going to check again? So mid, is R of mid greater than R of R? No, it is not. It is not, right? This condition, R of mid. R of mid is this and R of R is this, right? So it is not greater, right? That means this condition will execute. So R will point here. Okay. R will point here. So what is, so R L and R both are pointing at the same location, L and R, and hence this condition is going to break because we what this while loop is L less than R, which is not the case. L is equal to R, and what we're going to do at the end. So wherever the left pointer is pointing, once the while loop breaks, right? So that will be the minimum element. We are going to return R of L. Okay, return R of L, which is this particular element. Okay, so I hope you have got the intuition. Okay, I think you'll understand better with the code. Before going to the code, I'll request you to please subscribe to the channel, like the video. Okay, let's quickly implement L equal to 0 into R equal to R dot length minus 1. Okay, I'm going to say. So first I'll show Java code followed by C++. Okay, so while L is less than R, okay, so what we're going to do, mid equal to, let's say, uh, L plus for bigger numbers, right? I mean, the array size can be huge. So in this case, it should not get overflowed, right? That is why we do this L plus by 2. Okay, by 2 we do. And then what we're going to check here is if our conditions, I've already explained this, these conditions, right? So first of all, yeah. So first of all, if R of mid is greater than R of R, right? R of R. That means the smaller element is on the right side, and hence we are going to do L equal to mid plus 1, right? Else the element is on the left side, so we are going to do right equal to mid, and finally what we're going to do, return R of mid, right? Sorry, not mid, my bad. It should be L, R of L. So once the while loop breaks, right? Wherever L is pointing, that definitely it is going to be the minimum element. You can try with more examples. Okay. So let's submit it. Okay, the test cases are passed. Thanks for watching. So what will be time complexity quickly? It is going to be O log n. Okay, the binary search definitely takes O log n. Okay, to search an element. Okay, thanks for watching. Don't forget to subscribe to the channel, like the video. Let's quickly see the C++ code as well. So not much difference. Yeah, the C++ code is here. Okay, and yeah, this is an optimized case, right? Which we could have used in our Java code as well. So what it was, 1, 2, for example, if the array is already sorted, okay, and L is here, right? L is here and R is here, right? So if R of L, if it is already less than R of R, that means this is the minimum element, and hence return this, right? R of left. Okay. We can use this definitely. I'll add the code when I add the code in the YouTube, right? In the with the video. So I'll also add this particular condition in Java code as well. Okay. So yeah. So while L left, right? So I've already explained this, right? While explaining the Java code. Okay. So I'll attach the code in the comment section or in the description. Okay. Thanks for watching. Don't forget to subscribe to the channel, like the video. Have a happy, healthy, wealthy, and a great day. Thank you so much.